Guys, in my previous video, I asked you a question which none of you could give a correct answer. The question was, how could we reduce the magnetic locking in a DC motor? So here I'm going to answer you the question. So that is by making a skew rotor. That is going to reduce the magnetic locking between the rotor poles and the stator poles. Technique is usually used in servo motors. This is a servo motor that I am opening in front of you, and you will see a skewed rotor inside. The question for this video is what is a servo motor? Again, what is a servo motor?
Hi guys, you're watching channel Mr. Electron, and today in this video I'm going to salvage some useful components from an old dead 1 kilowatts 20 years old home inverter. So guys, here as you can see that finally I have managed to salvage this huge transformer from the inverter. As you can see, it is really big, and for comparison I'm going to use this small UPS transformer, and you can see how small this piece is when compared to the inverter transformer. Now these four wires that you see, these are quite thin, and if we move on to the other side, you see these wires, these are really thick when compared to the other side. So this side is going to be your high current low voltage side, so the other one is going to be your high voltage and low current side. Now comes the part of finding out which wires should we connect to the supply. So here I'm going to use this multimeter, and let's point the meter to resistance checking mode. So first let's check these two wires, and here we have 3.3 ohms. Now let's go for these two, 4.5, which is a little higher. Now the last one, 4.7 or 6, so it is the highest of the rest. So we are going to use these two for connecting to the mains. But before you proceed with that step, always perform the series connection test. So for that you are going to need one 100 watts bulb and connect two wires like this. You see, these are jumper wires. So two wires connected over here like this. Next, take one of the wire and connect it to the transformer. So now we have two left out wires in total, this one and this one. So these two will be connected to our home socket supply. So I'm going to use this for powering up my transformer. One wire connected. Now comes the other one. Yeah, and here we are done. Now let's turn on the switch. Now this bulb should glow a little bit if it's working. I'm not sure if it is glowing or not. Yeah, and now it is glowing. I think you can see. I'm going to turn off the lights. So it is glowing, really dim, but yes, it is glowing. And the next part is measuring the voltage at the output wires. So for that, I'm going to reuse my multimeter, and this time the pointer has to be set at AC voltage measurement mode. So yes, I think it's clear enough. First, I'm going to measure this voltage. As you can see that it is 9.68 volts AC. So of course it is working. Let's move on to the other one. And this one is also the same, 9.68. Now this one and this one. And it is as high as 20 volts AC. Quite high. So yes, our transformer is working perfectly fine. And one final thing, short circuit these two wires. Okay, I'm going to touch them and the bulb should glow brighter. You see, it's glowing bright, which means that the wiring that we have done is perfectly fine. Same for the other one, and these two also. Nice. So here we have a great salvage this time, a huge transformer. So this time it is a little dangerous. One wire connected, comes the other one. Now let's turn it on. Nothing happened. Okay. Well, I didn't hear any humming sound, so let's connect this bulb at the load. You can see it is 24 volts and 250 watts. Okay, so turning it on once again. Yeah, so the transformer is so efficient that there is no humming sound at all. It is silent, actually silent. Nice. Now let's increase the input power to the bulb, since it is a 24 volts bulb, and the good thing is that we have that combination. Now turning it on once again. You see, it is much brighter this time. Wow. Let's turn off the lights. Turning it on. Whoa. It is smoking hot. So that's our bulb. It's connected like this, and this time I'm going to turn it on and let you hear the humming sound. Let me know if any. Do you hear anything? So here I'm going to do some ampere measurement, 600 amps. So at present it is DC. Now it is AC RMS. Turning it on. Here we have around 9.5 amperes. Nice. So guys, finally the components that I have salvaged are one socket, two switches, high ampere switches, one small transformer for operating the relay, one PCB with so many components and heat sinks, MOSFETs, one huge relay case for future use, and most important, a transformer, 1 kilowatt transformer. Now guys, this is what I 3D printed this time. So this is the screw, and it's going to go like this. So link to buy this product has been provided in the description. You can check it out from there. And yes, of course, it is free for first 12 hours. So this is how you are going to assemble it. Now comes its use. So this, what you see, is a multimeter, and at the back of it you can see the double-sided tape. So all you have to do is take your multimeter, it can be any multimeter, and stick this piece at the back of it like this, and you're done. So this piece is going to be your multimeter stand. Okay, it works quite nice. Now here, as you can see, that the display is really dim, so I'm going to adjust it. And here we have it, even better this time. So this is how we are going to use it. It's quite simple and easy, and the best part is that this stand does not makes this meter bulky. It is still quite handy. You can still use the clamp meter without any problem. And when you need the stand, you just open it and you have it.
Hi guys, today in this video I'm going to make a 220 volts to 9 volts DC supply, high current 20 amperes. So for that I'm going to use this UPS transformer, which produces an output of somewhere around 9 volts with an input of 20 volts. Other components are this KBPC 3510 rectifier and this 74,000 microfarad and 16 volts capacitor, some clips and bolts. Now let's measure the resistance of this transformer's winding with the help of this must tool multimeter. And as you can see that the high voltage side resistance is 19 ohms and the high voltage other terminal is 4.6 ohms, which is not going to be needed. It is for operating the relay, I guess. Yeah. So for that reason I have removed it. Now let's cut a wooden piece that is going to be required for this project as the base stand. Now guys, I'm going to use this pin to feed 220 volts to the transformer. Let's see the wave oscillation AC. You can see that it is pure sine wave. You can buy this must tool multimeter from the link provided in the description. This is a 12 volts 5 amperes car headlamp bulb that I've connected to the secondary high current winding of the transformer. Now let's test it. Now for some reason the transformer is making a hissing sound and it is not working. Yeah, the bulb is also not glowing. Before the transformer burns out, let's disconnect it. So guys, I'm going to remove the transformer and replace it with this one, but let's check this one first. And as you can see that it is working perfectly and it is glowing the bulb pretty good. It is a 250 watts and 24 volts bulb. Okay, let's remove this one and replace it with the other one. Okay, testing again and it is working. Nice. Time to connect the rectifier. So guys, I have connected the AC terminals of the rectifier to the low voltage high current side of the transformer, and to the DC terminals of the rectifier I have connected it to the capacitor, considering the positive and negative terminals properly. Okay, now the AC pin has been connected to the high voltage side of the transformer. Let's measure the voltage with the help of these jumper cables. You can see that it is glowing the car indicator bulb quite good. Now link for the jumper cables and in connector box will also be provided in the description, so don't forget to check them out. You can see that the voltage output of this setup is 9.15 volts, which is exactly what we need, 9 volts. Let's try and glow this 12 volts bulb with it, and as you can see that it is glowing pretty good. Yeah, not fully bright because I'm not feeding it 12 volts, but yeah, bright enough. Same with the car headlamp bulb. Let's test some DC motors, for which I have actually made this power supply, DC power supply. Okay, now this is a 32 amperes 12 volts DC motor. You can see the high current winding. Let's connect it. You can see there is arcing because of the high current flow. It is working pretty smooth, although not much visible, but yeah, it is running. Now comes the centrifugal pump, which is a 15 amperes DC shunt motor 12 volts, General Electric. Now it takes huge current because it is a shunt motor. You can see how thick the cable is, and this supply should be able to run it. Also guys, polarity does not matters for shunt motors or any type of DC motors. You can see that it has started running pretty good even at 9 volts DC. Cool, right? Now this is a 24 volts 500 watts e-bike motor. You can see that the rated current is 26.7 amperes, and it is running pretty good at just 9 volts input. I got this motor from Bangwoods, and a link for this also will be provided in the description. It works pretty good. Now guys, this is a vacuum cleaner 12 volts 15 amperes, and as you can see that it is working pretty good, and it is for cars. I usually run it for cleaning dust on my table, working table. Okay, you can see that it is working nicely. Now let's go for the bike starter motor high current 110 amperes DC short circuit.
Hey guys, don't forget to subscribe my channel and hit that bell icon for similar video notifications. Also, do comment on what else you would like me to add to this present video. Best regards, Electron.